Hello, yeah, in this video I will talk about how to perform variable clustering in R using our package varclust. Okay. First, a few words about variable clustering in general. So the purpose of variable clustering is to group of variables with similar characteristics into clusters. Okay, so the usual cluster analysis are performed on observations. Okay, so or we have a data set, they're performed on rows of the data, which are observations from different individuals, which are assumed to be independent of each other. Okay, but when we measure variables, many variables may be related to each other. So we're interested in whether we can group them together into clusters based on some kind of similarity measure. Um, and the application of variable clustering is really for dimensionality reduction. So if we can group variables into different clusters, then the variable in the same cluster are more correlated than they are correlated with others. Then we, that may be biological meaningful by itself, but also we can continue to do data reduction. For example, we can perform principal component analysis inside each cluster, and then just use a few principal component to represent that cluster of variables. Then that achieves the dimension reduction. We get fewer number of, say, predictors if we want to build predictive models. Okay. And yeah, so this variable clustering is really useful when you have high dimensional correlated data. In this video, I'll just try the package varclust. I'll look at other R packages to see how they perform. Okay, so the first, let's just load in the package. I already pre-installed them here. Set a random seed. We generate the data. So we use 3 clusters, and for variable in each cluster is 5, sample size 200, and correlation strands. We're going to build some correlation among variables within each cluster. And then we use this function to generate the data. And then we do this for each cluster. And then we combine them together as a synthetic data. And then we add some random noise variables, another 5 variables. So we got 15 plus 5, 20 variables. Some are correlated, some are not correlated. And we'll see how variable clustering turns out. Okay. So the final data is a combination of synthetic data and noise data. And this is what it looks like. It has 20 columns. Okay. The first step for variable clustering is to standardize the data using the function scale. And then we need to use a function called mlcc.bic. So to estimate the number of clusters. So it will compute BIC values for the chosen number of clusters we are testing. So you can look at the syntax. It's mlcc.bic scale the data, then num.cluster equal to 1 to 10. So we're telling R that we want to experiment 1 cluster, 2 clusters, up to 10 clusters. Okay, and number of runs is 30, and then verbose to true. So it's going to print out the intermediate results. So let's do that. So it started computing and it spit out the BIC values for different number of clusters. And you can see it stopped at 7 clusters. You look on the right, that's the graph showing the BIC value it picked at the 6 clusters and start to drop at 7. So that's why R stopped there. This tells us the optimal number of clusters determined by this function is 6. Okay. And if we print out this object, it's a list. So the number of clusters is 6. And the segmentation tells us how the variables are clustered. So you can see the first few belong to cluster 3, and then cluster 5, cluster 2, and 4, and 6, and 1. So like cluster 6 and cluster 1 only have 1 variables in it. Okay. And so this clustering, variable clustering is not quite accurate, but we're just experimenting with this package here. Okay. So once you have the number of clusters, you can use other clustering method just to see how the clustering vary. So one method is the k-means, and you can print out the membership. So it changed compared to the like the first BIC, the MLCC BIC method. Okay, and also there's the third method called the reps. I think it's a subspace representation, and if you use that, specify 6 clusters, and this is the segmentation shows the different number of clusters. So you can see it varies quite a bit. So not sure. Maybe if we perform stability analysis, maybe the clusters are not quite stable here. But this is really exploratory analysis. I think once you have this clustering, you can look into the data and the meaning of all the variables and to see if these clustering makes sense. Okay, and we can do limited graphing. This is just showing you number of clusters and how many variables are clustered into that, you know, that cluster. Okay. Oh, there's the different clusters, 1 to 6, and how many variables are clustered into that cluster. So you can see cluster 2 has very few variables in it. Okay. All right. And after the kind of the simulated data example, I wanted to try this package on a somewhat real world data set. So I got this Gallup cancer gene expression data set. So I loaded up, and you can see it has 7,129 variables. So if I use this package, scale it, and then start to use mlcc.bic to run it, and it took 15 hours. It's a very, very long time. And eventually it stopped at 12 clusters. So the optimal number of clusters is 11. And this is the segmentation shows you which variable belong to which cluster. Okay. So I don't want you to wait for 15 hours. But this just lets you see that when we use this package, varclust, on real data set, when the number of variables is large, the computation becomes the issue. Okay. And again, whether this clustering makes a biological sense, that's another story. There you can do more investigation on that. But I just want to show you that using this package, it's possible that we can cluster over 7,000 variables into 11 clusters. Okay. All right. I hope this will get you started on variable clustering.